Can AI develop its own algorithms to speed up matrix multiplication, one of machine learning's most fundamental tasks? Hi there, tune in now. DeepMind unveiled AlphaTensor, the first artificial intelligence system for discovering novel, efficient, and provably correct algorithms, in a paper published today in Nature. Well, you'd be surprised to know that the research sheds light on a 50-year-old open question in mathematics about finding the fastest way to multiply two matrices. There's a lot more about this new AI breakthrough explosion. Let's find out. A key to increasing productivity. Increasing the effectiveness of algorithms for fundamental computations is an important task these days, because it influences the overall speed of a large number of computations, which can have a significant impact. Matrix multiplication is one such simple task that can be found in systems such as neural networks and scientific computing routines. Machine learning has the potential to outperform the most exemplary human-designed algorithms currently available. This process of automated algorithm discovery, however, is complicated due to the large number of possible algorithms. DeepMind recently made a groundbreaking discovery when it created AlphaTensor, the first ever artificial AI system for developing new, effective, and unquestionably correct algorithms for essential operations like matrix multiplication. Their approach provides an answer to a mathematical puzzle that has been posed for over 50 years. Just imagine. Let's rewind. Since the Strawson algorithm was published in 1969, computer scientists have been striving to outperform its speed of multiplying two matrices. While matrix multiplication is one of the most fundamental computational tasks, and as it turns out, one of the core mathematical operations in today's neural networks, it is also one of algebra's simplest operations, taught in high school math. Matrix multiplication is used to process smartphone images, understand speech commands, generate computer graphics for computer games, compress data, and other applications. Companies currently use expensive GPU hardware to improve matrix multiplication efficiency, so any additional speed would be game-changing in terms of cost reduction and energy savings. But guess what? AlphaTensor is based on AlphaZero, an agent that has demonstrated superhuman performance in board games such as chess and Go. This new work extends the AlphaZero journey beyond games and into the realm of unsolved mathematical problems. Oh, well, you can even try it yourself and give feedback in the comment section. Check out https://github.com/deepmind/AlphaTensor. The new AI explosion to improve computer science. This study looks into how artificial intelligence, AI, can be used to improve computer science. If we are able to use AI to find new algorithms for fundamental computational tasks, this has enormous potential, because we might be able to go beyond the algorithms that are currently used, which could lead to improved efficiency, said DeepMind's head of AI science. He explained that this is a particularly difficult task, because the process of discovering new algorithms is so difficult, and automating algorithmic discovery using AI requires a long and difficult reasoning process, from forming intuition about the algorithmic problem to actually writing a novel algorithm and proving that the algorithm is correct on specific instances. This is a difficult set of steps, and AI hasn't been very good at it, he said. A mind-boggling problem. According to him, DeepMind took on the matrix multiplication challenge because it's a well-known problem in computation. It's also a fascinating, mind-boggling problem, because matrix multiplication is something we learn in high school, he added. It's a very simple operation, but we don't currently know the best way to multiply these two sets of numbers. So that's very exciting for us as researchers to begin to understand this better. AlphaTensor discovered algorithms that are more efficient than the state-of-the-art for many matrix sizes, and outperforms human-designed ones. Apparently, AlphaTensor begins with no knowledge of the problem, and gradually learns and improves over time. So what happens is that it first discovers the classroom algorithm that was taught, and then it discovers historical algorithms like Strawson's, and eventually it surpasses them and discovers completely new algorithms that are faster than previous ones. Coley expressed hope that his paper will inspire others to use AI to guide algorithmic discovery for other fundamental computational tasks. Well, it is believed to be a significant step toward truly utilizing AI for algorithmic discovery. What do you think? AlphaTensor uses AlphaZero. It is actually AlphaZero that is running AlphaTensor as a single-player game behind the scenes. It's the same algorithm that was used to learn how to play chess that was used for matrix multiplication here, but it had to be extended to handle this infinitely larger space. But many of the components are the same. Indeed, DeepMind claims that the number of possible algorithms to consider is much greater than the number of atoms in the universe, even for small cases of matrix multiplication. The number of possible moves is 30 orders of magnitude greater than in Go, which has been an AI challenge for decades. The game is essentially about zeroing out the tensor, with some allowed moves that represent some algorithmic operations. This yields two critical outcomes. One is if you can completely decompose the tensor, you're guaranteed to have a provably correct algorithm. Second, the number of steps required to decompose this tensor actually indicates the algorithm's complexity, so it's extremely clean. According to DeepMind's paper, AlphaTensor discovers a larger space of matrix multiplication algorithms than previously thought, up to thousands for each size. AlphaTensor was chosen specifically to find algorithms that are fast on specific hardware, such as NVIDIA V100 GPU and Google TPU V2. These algorithms multiply large matrices 10 to 20% faster than commonly used algorithms on the same hardware, demonstrating AlphaTensor's versatility in optimizing arbitrary objectives. What is the matrix calculation exactly? Most of us encountered matrix multiplication for the first time in middle or high school. It consists of a predefined series of multiplications and additions used to find the product of two nth-degree tensors. The dot product of rows and columns is the most well-known method for multiplying two matrices. Outside of K-12 education, this mathematical operation has an impact on modern computing and is a foundational component of digital systems. Almost any data type that can be tokenized or encoded into a multidimensional numerical representation will necessitate some matrix multiplication. Matrix operations are extremely useful in image processing and computer vision applications. Discrete convolutions in a convolutional neural network are equivalent to taking a dot product between the filter weights and values beneath a filter. In other words, another matrix multiplication application. Mathematicians believed for hundreds of years that the standard dot product was the best and most efficient method for multiplying matrices. That is, until Kohlrausch-Strassen presented Strassen's algorithm, which shocked the world by demonstrating that more efficient algorithms exist. Strassen's algorithm used one fewer scalar multiplication than the standard method. Although Strassen's algorithm has fewer arithmetic operations, it's important to remember that on modern CPUs, a multiplier can produce a result every machine cycle, but so can an adder. The multiplier requires more gates and has a longer latency to obtain the first result, but they have the same throughput speed. Addition has a lower big O complexity than multiplication. Strassen was more efficient because he performed one fewer multiplication step. AlphaTensor takes this a step further by optimizing through self-play and reinforcement learning to discover new matrix multiplication algorithms. What is deep reinforcement learning? Deep reinforcement learning, DeepRL, uses deep neural networks to optimize a solution to a specific problem. There's use of the concepts of agents, environments, and rewards to model real-world systems in which an agent's goal is to maximize its reward in a given environment. Consider the game of chess, in which the goal is to capture your opponent's pieces and checkmate their king. In that case, there are optimal moves for every possible scenario on the board that will maximize the chances of success. The RL schema for this scenario could be defined as follows. The chess player would be the agent. The board and all the pieces would be the environment. The incentive structure is going to be like, firstly, add 2 points for moving close to the opponent's side of the board, 5 points for capturing a pawn, 10 points for capturing a knight or bishop, 50 points for capturing the queen, 10 points for losing any piece, 50 points for losing your queen. AlphaTensor performs a similar function in order to discover the most optimal combinations of mathematical operations for performing matrix multiplication in a novel and efficient manner. How is AlphaTensor automating algorithms? Now, this is something a lot of you might be wondering. DeepMind's reinforcement learning schema for optimizing the matrix multiplication problem was built using the concept of self-play. Their schema, as described in their paper, is as follows. The AlphaTensor agent begins with no knowledge of existing matrix multiplication algorithms and is responsible for compiling a set of operations to minimize the error between the correct matrix multiplication value and its result. The actual definition of the matrices being operated on is the environment. DeepMind employs a 3D tensor in this case. The reward is defined as a combination of the measure of error in the new algorithm's output and the number of steps required to zero out the tensor. This schema produces a search space in which the number of possible algorithms vastly outnumbers the number of atoms in the universe. For comparison, the number of possible moves in the game of Go, which DeepMind solved years ago, is 30 orders of magnitude less than the complexity encountered by AlphaTensor. AlphaTensor employs a novel neural network architecture that incorporates problem-specific inductive biases, a procedure to generate useful synthetic data, and a recipe to leverage problem symmetries to increase the feasibility of this effort. The DeepMind team noticed improvements in AlphaTensor's ability to rediscover feasible algorithms like Strasson's and eventually surpass human-defined methods in favor of algorithms faster than anything explored over time. Why is it such a big deal? AlphaTensor has aided in illuminating the breadth of matrix multiplication algorithms. These discoveries will undoubtedly shape the future of multidimensional data processing speed and efficiency. AlphaTensor has also demonstrated that machine learning techniques can be used to discover mathematical innovation that outperforms human creativity. This variant of deep reinforcement learning is still in its early stages, and the AlphaTensor work serves as a proof of concept rather than an immediate solution. This is a significant advancement in computational optimization and self-optimizing AGI, a delicate balance between humans and AI. DeepMind had previously worked on other extremely complex search spaces, such as the board game Go. The AI systems used to master Go, AlphaGo and AlphaZero, use deep reinforcement learning, which has proven to be particularly effective at tackling problems that cannot be solved using brute force search methods. However, in order to apply deep reinforcement learning to matrix decomposition, the researchers had to formulate the problem in a way that a model like AlphaZero could solve. As a result, they had to modify AlphaZero so that it could find optimal matrix multiplication algorithms. This is where the power of abstraction and analogy making shines brightest. Well, AlphaTensor, like Google's AI design chip and DeepMind's AlphaCode, is a prime example of how human intelligence and computing power can help solve interesting problems. Humans use their intuition, abstraction, and analogy-making abilities to formulate matrix decomposition into a problem that deep reinforcement learning can solve. Then, using computing power, AI systems search the vast space of possible solutions and selected potential candidates. This is a lethal combination that should not be overlooked. That said, what do you think about this AI breakthrough explosion? Isn't it just upscaling to progress and achieve a high level of advancement? What do you think about this? Comment down below. Share this video with all AI enthusiasts. Stay tuned for more.